Shall I start?
Yeah, I'll just introduce you briefly. So, welcome everyone. Glad that you were able to make the time to attend this session today. Uh, so, we will be having a session on about water filtration or how to figure out what kind of filter is needed, etc. Um, so, uh, I'll just give a brief background about Biome and also about our speaker today. So, for those of you who are unaware of our organization, we are Biome Environmental Trust. We are an NGO that works in water security, uh, water management to achieve water security, if I maybe put it, if I can put it that way. And very briefly, the areas that we work in. One is that our main program has been, or our main campaign has been Million Wells for Bengaluru, which is basically about replenishing the shallow aquifer. Shallow aquifer is the shallow groundwater that you see when you look down into a well. The water that you see, that is the shallow groundwater. And we are trying to see how to bring back the shallow aquifer into the imagination of people, because it was there before borewells came, and about how it can be made a very sustainable source of water, sustainable local source of water wherever it is present. So that's a very important uh, area that we are working in. Another area, and related to this, we are also looking at how wastewater, treating and reusing wastewater can be a climate mitigation strategy. And that is being actually helped by the Karnataka government's project, wherein they are pumping the treated sewage from Bangalore into several lakes in the hinterland. The purpose of that is to recharge the groundwater. And what we have seen is that when the groundwater is recharged in these lakes, the surrounding wells and bore wells, which had dried up, especially in drought hit areas, become active and they start holding water throughout the year, because the treated wastewater goes out every day. And in one of our projects, we have actually, uh, you know, uh, got this is in Devanahalli, where the town municipal council is now drawing water from one of the wells that we have revived, and Vikas has set up a treatment plant where the water is treated to drinking water standards and it is supplied to the town. It so augments the town's water supply. Then another area of work is where we work with rural NGOs to help revive local lakes. These are small lakes which are used as irrigation, used for irrigating farmland. So we're working, especially in Kolar, we are doing this, where we're working with a rural NGO. And also a very important area in which we've been working for many years is to foster water literacy in government schools. And we do this by setting up rainwater harvesting systems in government schools, especially in the outskirts. In the city, they still get water from BWSSB, but in the surrounding areas, it's a little difficult. So there, when we set up rainwater harvesting systems for them, they don't have to depend on the local water supply for at least the rainy months of the year. And through that, we kind of introduce the concept of water literacy and help them take ownership of the whole system. And then, of course, we also work with various communities within and around the city, where we empower people with knowledge to take ownership of their own water management, and to understand how water works and how to conserve water and how to become more water secure. So this is very briefly about what we do at Biome. If you have any queries, please do write to water@biome-solutions.com. That's our email ID. We also have our social media handles on Instagram and LinkedIn and Facebook, Biome Environmental Trust. So please follow us on those, and especially our Instagram. We put up several very interesting and posts, which are very informative posts on Instagram and on LinkedIn as well. Uh, and I would like to welcome with great pleasure Mr. Vikas Brahmavar, today's speaker. He is the director and founder of Trans Water Systems Private Limited, and uh, the brand of the water treatment plants that they put out is called Bosonwhitewater. He has over 12 years of experience in the water industry, and he's dedicated to creating sustainable water infrastructure in India. So he began by designing products to enhance water quality in both rural and urban areas, and has since been instrumental in developing comprehensive water treatment solutions. Vikas is passionate about advancing water sustainability and innovations in water treatment, and this makes him a sought after expert in the field. And we have been working with Transwater Systems and Vikas for many years now. In fact, he has been a speaker in both the TEDx's. We did two online TEDx's during the pandemic in 2020 and 2021, and he was a speaker in both of them. So those talks are available on our YouTube channel. I forgot to mention, please also go check out Biome Environmental Trust's YouTube channel, which has a lot of the recordings of these kinds of knowledge sessions, our TEDx recordings. So Vikas's talks are there on that as well. So welcome, Vikas. Thank you so much for making the time, and over to you.
Thank you. Thank you very much, madam. So it has always been a pleasure to work with Biome. So meaning the real intention of doing good things on the ground, that is what is inspiring. And each and everyone at Biome, starting from Vishwanath sir, Bhavani madam, Avinash, Shivanand, Uma madam, all of you. So it has been always a pleasure working with you. And thank you for giving us opportunity wherever we could possibly create awareness sessions. Thank you for giving me this opportunity on this new year. So I would like to wish all of you here a happy new year. I would like to start my session with this. So by the end of this next half an hour, 40 minutes, how much ever I'm going to talk. So the intention here is to pass on some knowledge, one or 2 points at least. If people take away with them, then that is the intention here. So I will try to stick on to as layman term as possible, but if it is technical, if there is any other confusion in terms of what I explain, it can be put in chat box and we can address all those later. Yeah, wonderful. So we all see different kinds of water, right? So how do we assess water? Whenever we go outside, go to a resort, go to a park, anywhere, we just see the sample, right? And say, what is the quality of water? This looks like good water. Can I have it? So that has always been the idea. Now, in this photo, I've shown two samples, two water samples. Which one is good? Good water. So can anyone say which one is good water? Right. So most of us will say the clear one is better water compared to the blue color one. Okay. But what we say, the blue color one is better water because it's just food essence. The transparent one is filled with heavy metals, chromium, cadmium, all these heavy metals are there in the transparent water. So the idea of this, to explain this, is we have gone beyond the point where we can say visibly when we see the water that it is good or bad. We as a country, the whole, most of the cities in our country, if we can't directly say whether water is good or bad, right? So this is one perspective in the urban area, at least. In the rural area, maybe there is low contamination, maybe it is not. But in the urban sector, in most places where people take sample either from a borewell or from any other surface, by visually we definitely can't say that it is good or bad, right? So one most important parameter comes just like we test blood, right? For any health hazard, we need to test water before we know what is the problem with the water, right? So my idea is not to scare people. My idea is to make people aware that testing makes things easier for people to decide, right? We have had cases in 2008 when we started. The average borewell depth in our country was between 700, 600, between 400 to 600 feet. People would average go. How do we know that? there are some borewell diggers who take contracts. They take borewell drilling contracts, right? They used to take contracts for 400 feet and above, right? Now, recently, 2020 onwards, people don't take lower digging contract. They don't take the contract itself. They take 1,000 feet as contract, right? So, because they have a feeling that if they dig 10 borewells, 8 borewells, if you dig 400 feet, you won't get water, right? So, and the blame comes on the borewell driller predominantly. It look like a waste of money for people. So, they take a minimum contract of 1,000 feet. Now we have been extracting water 1,000 feet below the ground. Little more we go, maybe we'll get oil also. So we are going that far away to reach water. Now it becomes critical for us to understand what is the composition of water. For anything to happen, sustainability to happen, for awareness to create, until otherwise we test the water, there won't be any concrete information which gets passed, concrete technology which can come into picture. Right? So I would start with basic water report. I'll take just 14 parameters. When you take a sample, you give it for testing. Generally, it goes to a laboratory which is NABL certified laboratory, right? It's a government certified laboratory. You ask for portability test, right? Then they give you a report which is 14 parameters, and the report will look like this. These are the first 7 parameters which is there in the water. The first point is turbidity. This is mostly visual. You can clearly say. So left side photo, if you see, the clearer the water, the lesser the turbidity. As it goes on, the turbidity increases, and less than 1 is the recommended level. So turbidity, basically on a layman term, it's a clarity of water. Technically, we have one more parameter which gets associated with turbidity, which is TSS, total suspended solids, right? The session might look like chemistry class for first 5-6 slides, but I will arrive at these details at later slides so it can relate. You can relate yourself. So TSS is total suspended solids. The particulate matter which is suspended in the water also contributes to the turbidity of the water. Right. The next parameter is pH value. pH is potential of hydrogen. So 6.5 and 8 is the limit for consumption. To give a layman perspective, our body's blood is 7.34 pH to 7.43 pH. If it is 6 pH, we are in coma. If it is 8 pH, we are in coma, right? So the pH is in log scale. So if someone loosely says my pH is 6, tomorrow it becomes 7.5, then you have to be careful with such term. pH is in log scale, right? So what is good as per IS 10500 standard? 6.5 to 8 is good for consumption for drinking water. The next parameter is total dissolved salts. Okay, this is known by most of them because we all buy water purifier. There is a purifier service person comes and dips a meter. Once he dips a meter, it shows a value which is total dissolved salts. It is the combination of all the dissolved minerals in the water, right? It can have calcium, magnesium, can have heavy metals, it can have anything in it. The meter passes electricity to the water and then it arrives at a value which is conductivity value, and total dissolved salts value is indicated there. So it indicates how much salt is present in the water. We should be clear that it indicates the salt level. It doesn't indicate the purity, but it is used in a very large extent for purity measurement. Because when people come and sell water purifier, this is, if they sell RO, this is the one which changes. So they have to show something which changes. So they end up showing total dissolved salts, TDS. Okay. Total hardness is generally a subset of total dissolved salts, where the amount of calcium and magnesium carbonates, these are the two salts where in your tabs you see scaling, white color scaling. If it is white in color, then generally it's because of calcium carbonate present in the water. So it will cause scales. The higher the value, it will cause scales. So that is one mineral. So when someone's, this total dissolved salts and total hardness is a very confused term in the industry. All of these parameters which is measured in ppm, parts per million, which is equivalent to milligrams per liter. So they take 1 liter of sample. In that 1 liter, how many milligrams of the salt is there is ppm. So milligram per liter and ppm is the same. Both hardness and TDS is measured in ppm. So we go to industries, builders, all of them. They say, tell me the ppm value. ppm is for both hardness, tds, everything is measured in ppm. So we should be clear that ppm is a unit of measure, and it is used to measure the dissolved minerals or any specific contaminant in the water in terms of milligrams per liter, right? So total hardness, if we reduce total hardness, your spotting scale formation will go down. That is one thing which we have to be aware of. The next parameter is calcium and magnesium. These are minerals present in water, standard minerals present in water. High calcium, higher the calcium, it can bond with carbonates and you can have increased calcium carbonate. Higher the magnesium, again, you have more carbonates in the water, you can have higher scaling. Next is chloride. Next parameter, if you see chloride, chloride is an important parameter for water being used for construction, right? And also for drinking, all it has to be less than 250. There are lots of parameters for it. But generally, people who measure chloride levels are people who are in the industry who use this for their construction, because there is a ratio called CSMR, chloride sulfate mass ratio, for which chloride becomes important. So this is one more parameter. Sodium chloride, common salt which we use. If you have softeners in your house and if you are sending the wastewater back to your borewell, your chloride levels will be higher over the next 4 years, 5 years. Your chloride levels in the ground will be higher if you're sending the salt reject. So for those who have softener, they put salt to maintain the softener. That salt reject is calcium chloride, which will increase the salt's chloride in the water. For this reason, softener based on salt was banned in the US in few cities because of this calcium chloride water being sent back to the cycle, where it's very difficult to remove higher chloride levels apart from membrane technology. Right? These 7 parameters are high level parameters. I'll go to the next 7 parameters. Fluoride. See now, these earlier these 7 parameters are generally talked by most of them in the industry. Now, few things which not every place they talk, few things they talk in region specific. So if you go to Tumkur region, if you go to few other region, Kollegala region, there are few regions where the fluoride level is very high, right? Fluorosis is a very, I put some numbers, I got few numbers. Pretty large number of people get affected with fluoride, right? So the water will still look clear. If you have fluoride in the water, it will still look clear. If you boil the water, fluoride doesn't go. So these are contaminants which are there in the water. We'll have to test it to know these values, right? It won't be present in most cases, but once it starts in a particular region, it's generally there for a long time. It will keep coming. It will, if it is say in 3 ppm, 4 ppm range, which is 4 milligrams per liter, generally in that area, there will always be fluoride. Next 10 years, there will always be, right? Total alkalinity. So this is again a factor of hardness, calcium carbon. So this alkalinity says how much acid you need to neutralize the whole water. So that is the measure of alkalinity. Again, this is used in construction industry, where they want to use this water for their construction and other application, right? Sulfate, again, sulfate is a problem. Too much of sulfate is a problem for construction, for a problem for skin, things like that. So there are various other problems with sulfates in the water. Iron causes skin decolorization, things like that. So we should know the limit is 0.3 ppm is iron. In Bangalore, Whitefield region, Ennore region has more iron in the water. So the easiest way to find is if someone adds chlorine, the whole water turns brownish in color. Or if you take a bucket of water and keep it aside for 30 minutes, 40 minutes in air, it will slowly turn brownish. Then it means that it has more than 1 ppm of iron. So we'll have to remove iron. Now comes nitrate. So nitrate issue is generally, so I'll give an example. So when we initially started, we went and met a customer in Basveshwar. Okay. He was above 70 and he said all the purifier nowadays people just do gimmick and sell. Do we really need any purifier? I have been drinking this water for the past 70 years. I'm really healthy, right? So in the same region, we did not want, generally, we don't want to push any product. So we're not in the game of pushing products. If they don't need, they should not use it. So we thought we'll just get the water tested, because 1 year ago on the same region we had got the water tested. It has some 12 ppm of nitrate, right? So we got the water tested. Surprisingly, around 312 ppm of nitrate was there. The TDS was only 700. So imagine having 345 ppm is the limit, and there is some 300 ppm of nitrate, and it is very dangerous. So what happens? Blood carries oxygen to various organs, right? So having nitrate in the water, which indirectly goes to the blood, reduces the oxygen carrying capacity of the blood itself, right? So it becomes really critical. So we told after the report, you have to put an RO. There is no other option. You have to remove nitrate. You can't drink it. It's okay. In 70 years, you didn't have nitrate contamination to this level. Now you have to have it. So after 6, 7 months, we noticed that the entire road, all of them started putting RO, and anyone referred, everyone had high nitrate on that. So what I'm saying is, without knowing this, without testing this, the water would have looked clear, we would have boiled and drank it. But how do we remove nitrate from the water, right? So this is one more parameter which I want to say. The other last two parameters are bacterial contamination, total coliforms and E. coli. So both, the government themselves say around 65% of all borewell water in Bangalore has E. coli and total coliforms. So, so generally, anything to do with bacteria, anything, we'll have stomach problem, we'll have 2 3 days of issues. But what we in the industry generally see is all these heavy metals coming into the water, all these poor autoimmune issues causing contaminants are bigger problem than the bacterial contamination. However, these two contamination also should not be there. Now, these are the standard parameters. As per IS 10514 parameters, these parameters minimum has to be tested for any water. So the general frequency now in Bangalore, at least 6 months once, people have to give the sample if you are using borewell water. If it is municipal water, most of these parameters are good, and it's in the range, most of the parameters. But it depends on the region. So I come to those slides little later. But if you're in the core region where the pipeline work is all done and you have a consistent water supply quantity and quality, then I think Kaveri water has most of the parameter addressed. Okay. Now, apart from these are the heavy metals. So in Pina region, we should be worried about cadmium, nickel. These two issues are there in Pina region. So all these minerals, they took a report of some 40 government buildings and they got it tested. Out of which, so if you see pre-monsoon, post-monsoon, most of it had these contamination. So there were two samples in zinc. Pre-monsoon, there was contamination. In cadmium, pre-monsoon, there was 35 samples which had contamination. So these are government places where they have done the tests. So what I'm saying is, without tests, we won't know. These are other heavy metals. Chromium is there in Pina region. In Harohalli region, there is chromium also. Chromium 6 is, there are variants of chromium which is very harmful. So we should be aware of what contaminants is there. So generally, if it is a layout or an apartment, there could be yearly once heavy metal test, which could be done at least for few parameters. If it is in Pina, probably chromium, cadmium, and nickel, all these can be tested. So if it is in Whitefield region, Hennur region, probably iron could be tested. So it becomes important for us to test these once in a while, at least yearly once. We should test the water for these. And the reason why we always say 6 months once testing is pre-monsoon, post-monsoon, we see significant difference. And year on year, there is significant difference based on the gradient, on where the surface water is flowing, where the sewage lines are changed. The quality drastically changes. So in Jagdish Nagar, we have noticed changes where organic contamination was not there at all. And just after few rains, there is severe organic contamination, and all the filters start choking. They buy borewell water or they buy tanker water, or they have their own. There's severe change in the quality of water, right? So before rain, during the rainy season, if you see, turbidity is generally higher, organic contaminants are generally higher, iron is low, nitrate is low, hardness is low, alkalinity is low, total coliforms and fecal coliforms are generally higher. Based on the reports which we have taken over the years, we see these are the values. And during summer, we see turbidity issues as lower, organic contamination is lesser, Iron, maybe precipitate is leaching out, iron is higher, nitrate suddenly becomes higher, hardness becomes higher. We generally assume that during rain, nitrate should become higher, but it's uta, maybe it is precipitating somewhere based on the details. But based on the reports, this is what we see. Fecal coliforms and total coliform generally is lower in the water during summer. The predominant reason, if you see, is surface water or the sewage contamination getting onto the main water streams and people extracting water from these sources. These are the main reason we assume. Okay. Now coming to most important parameter which we all keep asking. So total dissolved salts, because all of us have the meter in our house and we invariably measure the quality of water. We say purity of water based on TDS. So if you go to YouTube and search for TDS purity measurement, there will be 500 videos. Everyone will see the water is pure, the TDS is 40. See, the water is bad, the TDS is 1600. So I wanted to put some value so this myth goes away. So we'll go from bottom. Milk has a TDS of 1400 ppm to 2000 ppm. So is it not pure? So we should question ourselves. So the TDS is not a measurement to say the purity of water. TDS of demineralized water is 0 to 10 ppm. Tender coconut, if you buy, so if you buy a fresh tender coconut from for drinking water, it will be around 1600, 1800 ppm. But if you take a household which you use it for grating, you break the coconut which is old, it will have 3400 ppm TDS. Kaveri water is good. That is again, Kaveri water, any municipal water is good. Depends on the region. Kaveri water in Erode or Bangalore, after Bangalore, TDS is 400 to 600 ppm. Kaveri water at any house in Malleshwaram in Bangalore will be 130 ppm. Kaveri water before distribution, before they do cascade aeration, before they add chlorination is 90 ppm. Kaveri water in the river before and after rains are very much different. So if you see Kaveri water historically, so in Bangalore, we never had Kaveri water before the line 100 kilometers away was pumped to Bangalore. But historically, if you see human evolving near the lakes, near the rivers, they always consumed water between 10 and 30 ppm most of the time. So now we are worried about low minerals, high minerals, all that debate. But it was 30 ppm, 40 ppm. If you go to the Talakaveri river and take ppm, it will be 20, 30 ppm. It has less mineral in it. The problem is not the mineral, the problem is other parameters along with the mineral. So that is what we should be aware. So we should not judge based on the total dissolved salts in the water. Now, again, historically, what used to happen is rivers used to flow to multiple lakes across various salt beds. It would have accumulated calcites along the way. There will be higher minerals from the pond. There will be higher minerals in the lakes than the river. So lake establishment they used to grow better vegetables based on the mineral content. In the river region, there used to be some kind of crop which used to grow. So all these historically, if you see, the total dissolved salts is always less, but the other contaminants were not there, right? So this point we should remember. If someone next time talks about our meat TDS is too low, then the question is to make them understand that TDS low is not the problem. What is the other parameters in the water? Your TDS is 20 ppm and you have 5 ppm of nitrate, then it's a problem. So it's the composition of all these minerals together. Is it balanced water with TDS or is it non-balanced water with TDS? So that is one important parameter we'll have to look at. Right? Okay. So this table, we use it as a reference whenever we design any water treatment plant. We use this table, this graph as a reference. So if you see hair, a strand of hair is around 80 micron, 80 to 100 micron. So we can physically see. So particles from 100 to 1000 micron, right? Beach sand is between 100 and 1000 micron. A different contaminants falls in different sizes. So as a layman, we just have to assume that different particle comes of different size. We have a football of big size. We have tennis ball of small size. We have table tennis ball of small size. So like that, different contaminants is of different sizes, right? The idea of filtration is to remove particles, assuming you have a cloth, right? Based on the pore size or based on the whole size of the cloth, the contaminants you put on the cloth gets filtered, right? So like this, if you see, there are different, at the bottom most column, you see different technologies which are used for different types, particle sizes of filtration, right? So if your water has very high bacteria, particulate filtration will work up to 1 micron. Particle filtration will work, but there are few bacteria which are lower than 1 micron size. So you will have to specifically remove. So say we go to say Kanakpura Road, right? If the water, if there is a lake and the lake is completely contaminated with the sources, with organic, inorganic, what contaminants, and you have a tanker water or a borewell next to the lake, and it's a contaminated lake, you end up having different types of bacteria. 1 micron filtration might not work. So you might have to remove a specific cryptosporidium, which is say 1 to 10 micron, or any specific virus which are even smaller, 0.01 micron. So we should be sure on what product to use for different contaminants, right? Now, this chart we use for designing. Now, if the water sample consistently 2-3 times does not have any other contaminants apart from basic bacterial contamination, we just need a zero point 0.1 micron filter and a UV disinfection, and we can take the water and save for consumption because there is no other contaminants. So, but we won't know until we test. So, based on the test reports, we decide, and it's not one test report. It's a consistent composite sampling, we call it composite sampling test report. Based on that, we design. So for those of you who have to understand little technically oriented, this sheet can be used for deciding whether what contaminants is there in the water. But generally, when a laboratory gives, they give this 14 parameter report. Based on that, you generally won't know. But if there is heavy metals, metal ion, any of this, if you have cadmium in it, then it means metal ion. Even if your TDS is 300 ppm and if it says traces of cadmium, you can't do anything. You have to put an arrow because metal ions doesn't get removed apart from anything apart from, right? Okay. Now, I would like to differentiate between filtration and treatment. This is very important because the terms in our industry gets loosely used because it's installed by people who don't get enough training to explain it fully. So we should be aware of what is filtration, what is treatment, right? What is filtration? What do we normally call as filtration? Filtration is physically removing some contaminant from the water. Say your water is filled with leaves, it has 40 leaves in it, right? So you put a cloth, you pour the water, you're filtering the leaves, you have water below. So that is physical filtration, right? What is treatment? Treatment is, say you take a sample of water, you add few drops of chlorine or you add alum to settle it, right? So you're not physically removing anything from the water. You're doing some treatment for contaminants to either settle down or react in a way where it is not harmful, right? So this is a significant difference. So if a purifier guy come and says that I'm giving you an activated carbon filter and a UV filter, then it is not a filter, you're just doing a treatment. So you should be aware that you're not removing anything from the system. You're just doing some treatment. Say TOCs gets reduced with carbon filter, UV filter kills bacteria, but your water comes out. There is no physical filtration. Maybe carbon does some filtration, but it is not meant for filtration. It is meant for treatment, right? These two terms are very important to use. Maybe the guy who's supplying won't know, but when you buy purifier, you should be able to differentiate what is a filter, what is a treatment, right? Olden days, when we were kids, we used to have this stainless steel filter, candle filter inside our house. Dad used to take one bucket and pour the water on the top container. There used to be a ceramic filter inside. Slowly, water on gravity will come to the lower portion. Water will look clear. We drink it, right? That is basic ceramic filters. Ceramic filters are available from zero point 0.1 micron to 130 micron, right? At that point of time, probably 10, 15 years, there were 10 micron, 20 micron ceramic filters. So every 3 years or 4 years, if there is a lot of contamination, probably 6 months it would fail. There will be someone will come and change the candle and water. So it was so easy. We never worried about quality. We never worried about any contamination at that point of time. But a few people say because you are in industry, you kept on seeing water report for a long time. You're now paranoid that you worry too much about water. But we have seen people having the adverse effect over the years. So from outside, we are clearly able to see that they are having problems. So we end up saying something complex to them. But I wish we can move back to a stage where we had good water. We never had to worry about nitrates at 200 ppm. But we have, it feels bad to say that we have gone beyond the point. All the cities. So we thought Bangalore, okay, let's see Chennai. Chennai is also contaminated. We went to Pune. They said the TDS is too low. The TDS was 140 ppm. We got the water tested. It has 1.6 ppm of iron. So what do we do now? Every place there is one or the other thing coming onto the water. Either it is because of our fast growth, but it is again debatable. Do we need this growth? Do we not need to do? Not a point of topic of discussion now, but we are beyond that point is what we feel in terms of water contamination. Now coming to filtration is physical removal of contaminants. So all the listed ones, RO is a filtration. RO, when you buy an RO purifier, there will be treatment and filtration. So the membrane blue color which you see, that is an RO membrane, which is used in a domestic house, blue color thing which you see. The left side, that is an industrial RO membrane which you see. There is UF membrane, the third image from the left. That is a UF ultra filtration membrane, which is there. So I'll come to what micron each one will remove. But these are all filters. Okay. What is treatment? UV is a treatment. So we get different rays. UV rays, 254 nanometers kills bacteria. When UV rays of 254 nanometer passes onto the water, the bacteria's outer shell gets cracked, so it can't reproduce, it can't create any negative effects. So basically you're disinfecting, which means that the bacteria is not alive in the water, but it is still there in the water. If you pass the water through UV, the outer shell of the virus dies. UV system is a point of use system, we should be aware. If you take the UV treated water, put it in a tank, after 8 hours you will still have bacteria. 6 to 8 hours before that, if you take the water, then UV treated water is okay, right? UV is ultraviolet. Okay, I'll come to UF little later. Ultra filtration I'll come later. That is a filter. UV is a treatment. Okay, there is ozone treatment where it takes air, oxygen from air, and converts it to O3, and it kills bacteria. It breaks open the virus fully, right? It doesn't crack the layer, it breaks open the virus fully. So it takes generally 24 to 28 hours, some people say up to 36 hours, for the bacteria to regrow. So that can be used in places where within a day someone uses the water, there won't be bacterial growth. So after UV, it's ozone. So some swimming pool, they use ozone system instead of UV, right? For all point of view system, where in your kitchen, if you're just taking the tap, UV is sufficient, it disinfect because you're just consuming it after that, right? For bacterial contamination. Other treatments are adding chlorine, adding alum. All these are different methods to kill bacteria. There is good and bad of it. Too much of anything is bad. So chlorine, some people, I've seen chlorine, people take one full packet of chlorine and dump it in the sump. There'll be huge amount of chloramines coming into this. It's carcinogenic. Never play with chlorine is what we say. People who use chlorine, be careful on how much chlorine you're adding. We are always hesitant. So even for the Biome Academy project, we're so hesitant to add chlorine. It's way below the limit for disinfection, but it's always needs to be added in quantity. But however, Kaveri water, when you open your sump, will have a lot of chlorine in it. So chlorine, alum, all these needs to be carefully added on based on how much it needs to be added. General chlorine level is less than 1 ppm. 1 milligrams per liter is what people have to add. Less than that, anything more than that is generally you will have chlorine smell, all that. Swimming pool, they maintain at 1.2, 1.5 ppm. Right. Now, few filters which we buy in the market is mix of all these. When you buy a normal water purifier, it will have treatment, it will have filtration, it will have all these in combination. The normal sand filter which people put at home is a mix. It does filtration up to 80, 100 micron, and it also removes TSS, turbidity, all that normal sand filter. Carbon filter is such an amazing product. So we like carbon filter so much. It is made from coconut shell. Most of the cases there is synthetic carbon also available in the market. There are few contaminants which gets removed only by carbon. even RO doesn't remove. So there are few chlorine compounds. When you put chlorine into the water, there is a there are different salts of chlorine, THM they call it, different salts of chlorine which comes, which are carcinogenic. It gets absorbed onto the surface of the carbon, right? So carbon filter in any purifier, any water, you carbon filter, Kaveri for Kaveri water, carbon filters, you need that basic carbon filter where if they have high chlorine in the water, in the municipal supply, let it pass through carbon, chlorine will go down, and then you take the water, so chlorine is gone. TOCs gets reduced, smell gets reduced, color gets reduced. Carbon filter is such a thing, but carbon filter again, if you don't change it, right, the small carbon fines will still pass through the water. That is harmful, right? So the idea of any purifier is to change it regularly. Cartridges to be changed regularly. That is one most important thing. Resin, softener, all these are mixed treatment. So different contaminants. Say if you want to remove fluoride from water, there is different resins which are available which remove fluoride. If you want to remove nitrate, different materials which are available. In the market, when you see your neighbor, they would have put a cylinder, right? Generally, anyone puts a cylinder. Inside that, what they put really changes everything. I'll tell her. So we have sold water treatment plant based on what neighbor has bought. So we go to a meeting. No, my neighbor has put two cylinders. I will also put two cylinders. Don't give me one cylinder. So customers say that. See, sometimes it is bad to have unnecessary filters. See, I'll tell you why. So someone puts a filter, sand filter. You have silica leaching after 10 months, 12 months. You have silica leaching possible based on your incoming. There will be silica leaching coming out. So it does more harm than good in some cases. So we should never decide what neighbor has and then buy, or what someone in Pune has, what someone in Chennai has, what someone in Whitefield has, what someone in HSR has. Now we have just gone to that level, right? So we don't put filters if it is not required, because there could be negative aspects for it if it is not done, because it's a commodity in the market. People randomly buy for the sake of buying. Someone builds a 3 crore villa, they want to see three cylinders there, right? So meaning sometimes it does more harm. So they you should put only if it is necessary. So that is first part. Some people don't put it in the other way around. So meaning they say there are extremes. They say I'm environment friendly. I have always had natural water. I don't put anything. Meaning it cannot be extremes. Also, we should go with what is there in the water and not based on anything else. Right? Okay. So what does each of these filters filter? Right? So olden cartridge based filters, the normal cartridge in any purifier, they'll have a cartridge white color, either melt blown, it will be smooth white color filter, or it will be a ring thread sort of filter. So both are cartridge filter. It is available from zero point 0.2, 0.1 micron to 100 micron, based on what they put, based on the cost, based on various parameters. There are different micron sizes. Now, where do we use this? If you're sure you're getting just municipal water and there is no contaminants in the water, then basic filtration for dust particles, basic level contamination, this cartridge is sufficient, right? Now, cartridge doesn't remove bacteria to a most extent. There is some bacteria it doesn't remove, but after boiling, bacteria might go. So when you put a cartridge filter, you should be sure that the water has no other contaminants, but just a basic cartridge filter. Activated carbon filter, there are different grades of carbon based on the iodine value of the carbon. So they grade it based on iodine value of the carbon which you buy, right? So the higher the iodine value is better for absorption. More contaminants gets absorbed. So it ranges from, you should be aware that in the market, you get carbon for 30 rupees per kg to 450 rupees per kg. Okay. There are different brands. There are used carbon sold in the market. Say you have an STP plant in your apartment. Whenever there is change, there is like few tons of carbon which is coming out. You just wash it, dry it, reuse it. That's also carbon, right? So you should be aware what grade of carbon you're buying. Is it fine? Is it granule? There are carbon blocks which is available. Based on the need of the water, people decide on the type of the carbon. At Devanelli project, we use 900 to 1000 iodine value carbon, right? So higher adsorption, it will remove smell to a certain extent, color to a certain extent, and TOC is total organic contamination just by adsorption. So water when it passes, it goes sits on these and then you will need pressure to wash it back. So you do something called backwash and take all the contaminants out, right? Carbon is currently you have municipal water carbon filter with cartridge will do a lot of good things for a lot of contaminants for safety. You should have cartridge and activated carbon, right? Now carbon is a big industry where a lot of scientific innovations are happening, where people take carbon, do special impregnation on the carbon, and they make it remove very specific contaminants also along with the other contaminants, right? There are few dyes, textile dyes, which is getting removed with carbon, and there are a lot of research going on in carbon. So it is an amazing industry to work, but that's what the coconut shell is the base for most of the carbon. There is synthetic carbon as well, but the best performing ones are coconut shell carbon. Right. Next, UV, I said UV is a nanometer. There is 185 nanometers, I think, and 254 nanometers. These are the two types of UV rays which is available. 254 is the most common one. In your house purifier, that is what you get. Inside a UV system, there is a tube, quartz tube. So it passes rays. So generally, UV system is cheaper. You just have need a basic electricity. It produces UV rays and kills. So that is a point of use. As I said, 6 to 8 hours is the effectiveness. So if you have a UV before your overhead tank, generally it's not effective because you end up storing it. There is water at the bottom, so it's not effective. It is after the storage tank. If you have UV, it is effective. Now comes ultra filtration. Right now, so far it's all treatment. Now I'm talking about filtration. Okay. Ultra filtration range is 0.01 micron to 0.001 to anything down to 0.01 micron, right? Some viruses come in that bracket. Some pigments also come in that bracket, but none of the dissolved salts get removed with ultra filtration, right? Um, Ultra filtration is a filtration technology where there is a it looks like a cartridge. It you take in the water, it filters particle down to 0.01 micron. Right? It doesn't remove minerals. It removes most of the 99% of the bacteria. It doesn't remove gases. It doesn't remove dissolvement. It doesn't remove heavy metals and things like that. But it removes most of the contaminants. It requires little pressure compared to RO or other technologies. But ultrafiltration is a good technology. The issue is it is not as commoditized as an RO system, right? So when you buy a purifier and you have a municipal water, if the purifier guy says, "I'll give you a cartridge filter, I'll give you a carbon filter, I'll give you a ultra filtration, and then a UV at point of use," then that is a fairly good system to handle most of the contaminants. Generally, this is sufficient for people those who are worried about wastewater, waste going. This will ultra filtration will have very low 10% wastewater compared to RO or other things. So, but the idea is how do you find whether it's ultra filtration? As a common man, we won't even know the difference between a cartridge filter and an ultra filter. So we'll have to be careful whether we are buying the right ultra filter for our system. Right. Then further down, nano filtration available, that is also not commercially easily available. You can't have an NF small membrane. It is available, but you need to know which brand to buy, whether it is really nano filtration. Nano filtration is even further filtration. Many of the contaminants gets removed better than in terms of filtration, better than ultra filtration. It still doesn't remove some of the dissolved. There will be some reduction in calcium and magnesium components, but it wouldn't remove everything. Then comes RO, the most debated purifier. RO, good, bad. I have a few slides on that as well. So RO does remove everything. Basically. It removes good, bad, ugly, every sort of contamination down to 0.0001. It removes everything. Right? It removes everything almost equally. That is why it is commercially available easily in the market. Because see, when you have a balanced water coming in, this will give almost balanced water going out, right? So it will do maximum filtration, but there is a lot of problems in terms of wastewater, all the problems. But if you are a person never test your water, you don't know what is coming in. I just don't have to worry about anything. I don't have to worry about service. So many companies are there. I'll put some purifier and not worry about anything. Then most cases people end up putting RO because of the service network, because of the water testing not being done regularly. things like that, it becomes easy for people to decide and sell. And people who sell also, does it remove heavy metals? Yes. Does it remove pigments? Yes. Does it remove nitrate? Yes. It will remove everything, right? So it is a very effective filtration. I have few slides on the problems of that as well. So with outlet of the RO has less pH. What happens when you remove most of the minerals when water comes out from the air? From the air, it absorbs CO2 and it becomes carbonic acid. So when carbonic acid is in the water, it will reduce the pH. Any acid in the water will reduce the pH. So there will be zero point 0.5 to 1 pH 1 pH reduction in and out, based on your incoming water, based on the CO2 level in the water, based on atmospheric CO2, there will be reduction in pH after RO. So that is a bigger problem than the salt reduction. So we should be aware when we say if it is a 7.5 or 8 pH water going in, then generally the salt reduction is not a problem. pH also would not have reduced drastically. So we should worry about pH reduction more than the salt reduction. Ozonation, as I said, is a disinfection. 36 or 25, 24 to 30. You can store it. It breaks open the shell of the virus or bacteria. It's a good technology for disinfection. Not many brands are available for ozone. And it is costlier, way costlier compared to UV. So people don't adopt ozone. So it is not available as much as a UV. There are so many other treatment methods, which graphene based treatment, carbon nanotubes based treatment. So many technologies have come up, but commercially, so when someone buys a purifier, they won't have access to plasma technology, they won't have access to all other technologies which are costlier. They get access to technologies which are easily usable, easily serviceable, right? Okay. I think all the points which I've discussed before, there are good, bad, ugly. So I will go with RO RO, because we've almost finished time. So I'll go with RO. So RO, as I said, has, for a domestic scale, when we say reverse osmosis, it has 3 times generally wastewater. So every 1 liter of water, good water comes, 3 liters of water gets wasted. But in an industrial scale, as we increase the size, for we can get it to 80% recovery, 90% recovery. Give 100 liters, you can recover 90%. So as a technology on an industrial scale, it works really well. But on a domestic scale, there is a huge quantity of wastewater. So for people who are worried about wastewater, people who are worried about doing the right thing for the house, if they spend some time understanding their water, they can possibly avoid RO and opt for UF or some other alternate technology. But without testing water, if someone puts it, ends up invariably RO system. Right? I'll share this slide so all the other technical details are there. So there are a few debates I would like to close in this slides. So is RO purifier bad? It depends on your input water. We should be clear. So we can't generalize saying that RO purifier is bad, right? There has been a Czech Republic report which came saying that RO, when you drink RO water, all the minerals in the body go away. It eats up all the minerals. That report, if you see all the references is for the Czech water. The TDS is 60 ppm. So you give 60 ppm input water to an RO, it becomes 5 ppm. It becomes demineralized, right? So when you have such cases of water coming in, then RO purifier could be bad, right? In our case, when you're using 1000 ppm, 700 ppm water, then you need RO purifier because there are too many contaminants in the water. Recent government, there is debate happening. Government has told less than 500 ppm, you generally don't need an RO, right? We should not go blindly also on that. If your water is less than 500 ppm, and if you have fluoride of 2 ppm, then you need RO, right? If you have TDS of 400 ppm, nitrate of 35 40 ppm nitrate, you need an RO. If you have 400 ppm, all the other parameters are balanced, you don't need an RO. So before deciding or before saying it is bad, good, it is depending on the water, right? Second big debate is happening on this wastewater with RO. Generally, with this wastewater, uh, now we as consumers so are worried about water we drink. A normal person say 2 liter, 3 liter we get, for every 3 liter we ended up wasting 10 liters, right? Our perspective after so many years in the industry, our perspective is now we are able to see this water going down the drain as wastewater. But when we have shower, when we flush toilets, when we bathe, there is significantly large quantity of water which is getting wasted. So we went to an apartment association discussion, said RO is wasting water, wasting water. But on the STP treated water, they were wasting 50,000 liters of water every day. After treatment, they were just draining it to the drain. Now, what what we normally say is if you are able to map this RO wastewater directly to your STP, it wouldn't harm the STP because very large, very small quantity of RO wastewater. Per capita, if you see, with RO, you will end up wasting 10 liters of water. But the same person will waste 90 liters of water completely to the drain without any reuse. So that is the perspective we want people to see. You don't just see what you see in your kitchen, you also see what goes out as complete wastewater. So that is a perspective we should see before saying it is bad, good. Next is there is huge number of products on network marketing being sold for alkaline water, increasing pH, decreasing pH. Right? We've there are also some doctors promoting systems. See, all these products which are working on artificially increasing any of these components, right? They were specifically done for some other purpose, right? So people were washed with heavy alkaline water to have radiation effects in Japan when they had this. They used with large amount of alkaline material to wash away the body with different contaminants. Right? It was meant for a different purpose. Right? Your normal acidity. You eat one burger, you eat one pizza, and you have some acidity sensation. Don't switch to complete alkaline water. Don't start having 8 pH water, 9 pH water. We have had friends who are doctors. The urine's pH has changed for people over the years because they bought some 2.5 lakh worth costly machine and kept on having 8 pH waters because someone said that high pH water is good, high alkaline. So it depends. So what we have seen to work is our blood's pH is between 7.34 and 7.43. Right? We have always had water in this pH range. It is better to stick with this until otherwise you're medically advised to have something higher because you're shifting to low pH range or because you shift to high pH range. We had people who had suddenly started getting eye twitching because having high pH water. So we should be careful in deciding whether it is working for us, it is not working. We should not go and fall for blind marketing just because it's network marketing. Someone is getting paid 50,000 rupees to sell one equipment additionally. We should not end up buying these systems. So we should be careful. So I'm not saying it is not good. It is good for few people. Few people have seen clear advantage because they know what they're buying. It cannot be a product which is one size fits all product. It's both with alkaline water and pH alterations. This pH is a gimmick. So someone shows you a glass of water turning blue, turning red, all that. So that is the normal marketing. I can put soap and show that it's become blue, right? So these are not really scientific. So we'll have to be really careful in what product we buy. And it is better to stay in the 7.34 to 7. Right? So before you buy water purifier, get your water tested. Understand good, bad of each technology. No technology is all good. No technology is all bad. Check for availability of service, and there is no one size fits all. I hope I added value during this session. Any further questions, anything, I'll be happy to answer. Thank you. Thank you very much for that.
Thank you so much, Vikas. That was very, very interesting and very useful, actually, because uh, especially the differentiation between treatment and filtration. Nobody tells us about that, right? So already, yes, hands are going up. Oh, Vihan has a question, but
No, I
Vihan,
think we'll leave it. I'll answer at home. So
no, no, it may be useful to everybody, but we'll go
okay,
based on who asked first. So,
sure.
Mr. Satyanarayana, please go ahead. Vihan, keep your hand up. We'll come to you.
Yeah. Good evening to all. Just I wanted to know two, three things.
Yes.
As per the Supreme Court order, the TDS is supposed to be maintained maybe between 200 to 250 ppm. As you said, TDS is not the prime factor to decide the quality of the water. So what we have to say, what we have to do, is it required that we have to maintain that 150 to 200, 250 ppm or not required?
Yeah, so IS standard says anything below 500 is good for drinking, right?
Okay.
But now, if the order specifically says it's for people who have higher TDS in the water, it doesn't say you have to not use RO for every kind of water. So it is specific for water quality. So, sir, I would say this TDS point, we should not worry about 200, 250. We should worry about the balanced whole water. So based on the entire water composition, if you don't have any other contaminants and your water value is 200, 250, then it's good, sir. No problem.
Okay, one more question, sir.
Yes, sir.
This I am using this decal because here the water in Visakhapatnam, I am speaking from Visakhapatnam.
Okay.
Here in Madhurivada area, the calcium hardness is around 1200 ppm in the bore water. So I am advised to use this decal candles. I am putting these candles in the overhead tank. Yeah, are these useful, sir, to reduce the hardness of the water?
Sir, when someone says hardness reduction, then
Yeah.
it is chemical removal of calcium carbonate and replacing it with sodium carbonate. So there will be a cylinder. Inside that, someone will put resin, pass the water, and that's the only way of removing hardness. What all others are called conditioners. So what it does is it neutralizes the calcium carbonate and magnesium carbonate ions, and it passes through the water. Those are not softener; those are conditioners. Sir, I can't comment on any specific brand or technology. So we have tried, tested all from 2008 we have been importing various conditioners, all these. So few are good, few work really well on laboratory condition, few work well when there is no chloride in the water. Few claim it works really well, but when we put in field it doesn't work. So for hardness, the easiest and most measurable way is the chemical reduction of hardness. But at 1200 ppm it becomes daunting to add salt and do it. So it doesn't do any harm to try that, but I would recommend you should get your water tested before and after. If you see significant difference, then it is helping you, then it is good. But for purifier at that level, you need RO at your drinking water level, because there will be some other mineral contaminants.
Thank you, sir.
Thank you, sir.
Go ahead, Vihan. Ask your question.
So, if anything is added to the water, would that affect the microbe quantity?
So it depends on what you add, Vihan. So if you add unwanted contaminants, it will affect the water. If you add minerals, sometimes it's good, sometimes it's bad. Too much of mineral is bad.
Thanks.
Yeah, okay.
Thanks. Okay. So there are a couple of questions in the chat. Manogna, would you like to unmute and ask the question?
Sure, Uma. Thank you, Mr. Vikas, for a fantastic session. The question I had is there any publicly available data, whether it is from BWSSP or from any other municipal body, on these important water parameters in the city, and how frequently is it even tested and monitored?
So we all rely on this IS 10 500 2012 standards for all the parameters in terms of what is expected for drinking water. See, but what has happened is we never believe in any of the government standards. We all go outside and drink buy bottled water, which is 50 ppm, 60 ppm. So with government, if we ask, then these are the only things which are available: IS 10 500, and there is no specific limit which says. The World Health WHO also standards is pretty high, but in terms of bottled water, all the parameters are very much lower compared to what IS says. So to answer your question, IS 10500 standard is the current available best benchmark to validate if the quality is good or bad. For calcium and magnesium levels, right? There are a huge number of international reports says. Some reports says it's good for heart fibers. Too much of, say, 400, 350 ppm heart fibers, it's good. Some report says it's good for heart fibers, but it's not good for some other organs in the body. So there is conflicting reports available for values being higher and lower. But on a high level, for a common man, IS 10500 standards are the reference.
Okay, thank you.
Thank you.
So I think you, Manungnai, also meant whether the BWSSB is putting out data about water quality testing in different areas of the city. That's what you're asking. I
That's also, yes, that's also what I wanted to know. Like, for instance, if I were to go and take my home water sample, like, go and get a test done. And if I want to do a comparison with, maybe the surrounding areas, let's say I'm from Jayanagar, but surrounding areas of the city, is there any way we can, know what is the current publicly available data?
So I'm not aware if they have, but for Kaveri water, I think in the BWSSB website, we should be able to get what they supply. But at each area, what is the quality? I'm not aware if they have put it in the website. I've seen it 1 year ago, but it was not there. But maybe it is there, but I'm not aware. See,
Okay.
the issue is even if they put it, right? So now if you take HSR layout, 19th Main, if you take the water sample from a borewell, it has hydrogen sulfide. But if you take it from 24th Main, it doesn't have hydrogen sulfide. So what do we do with any benchmarking is again a question, because see, the aquifers, if it was like 20 years ago, the aquifers was all constant. If someone used to discuss something in Chennai, so Bangalore water is this quality, Chennai water is this quality, Pune water is this, they used to discuss like that. Now we can't discuss that way because road wise it's become contaminated. We don't really know what is there in the next road. So aquifer has bifurcated, meaning fragmented so heavily that 50 meters down the road we really don't know, right? We have had such cases where one apartment on the compound next 40 meters there is different borewell and it's completely different water, so we don't know where it actually taps, right? On a government level, if you ask, so government spends 50,000 rupees per acre on the surface water, right? On all the Kaveri distribution channels, they've spent 50,000 rupees per acre, but we don't spend anything for below the ground. So any data which is available would most likely be obsolete because there is no mechanism easily to.
Very interesting. Thank you.
Thank you.
Yeah, plus also the BWSSB is very, very short staffed. So I don't really think they have the bandwidth to do any testing, even if it's there in their, that they should do it. But I doubt that will be the last thing on their list of things to do. So the best thing that we can do is test our water and see how it is.
Correct, 100%.
So then next question is from Mr. Ramesh Venkatraman. Did you address that in your answer? You spoke about magnesium and calcium levels, but this is regarding RO treated water. Ramesh, would you like to ask the question?
Yeah. Because I'm Ramesh from Chennai, thank you for a very nice presentation. I actually have two questions. After listening to you, I've added one more question. I have an acidity problem. So I recently bought an alkaline water pitcher. Now this pitcher comes with a cartridge, and the cartridge has activated charcoal, then some resin, and it has some alkaline mineral balls, etc. I try and mix it with normal water so that it doesn't go to 8.59, etc. I drink it at around 7.5, 8. That's what I'm hoping to drink. But my bigger concern is, will this cartridge grow bacteria? Because water is passing through it. That is my bigger concern. That is question number one. Question number two is the apartment complex where I live in has a centralized RO water plant. We took the water from the RO water plant and tested it, and the calcium and magnesium levels are much lower than the prescribed levels. So how do you manage that? You have to remineralize it. How do you manage that?
Right, sir.
Good question.
Sir, yeah, okay. So coming to the second question first. So your centralized RO, right? For that, this prescribed limit as per government is less than 500. So there is, it can be 20 also, it can be 400 also. So there is no specific level. They say you should have 200, you should have 150. There is no specific level, they say, right? So generally in Chennai, so it depends on your input water. So if the water is balanced at the outlet, and if you have say calcium and magnesium at 30 ppm, 40 ppm, then I think it should be good. It should not be 0, 3, 2, then you need mineralization. Now, remineralization is a big topic. Now, we have done lots of bottled water plants. in those bottled water plants, they end up adding different kinds of cartridge like you have in your house, remineralization cartridge. This activated charcoal, which you said is good. This resin based, I don't know what resin it is. Maybe there is fluoride, fluor removal, or any other specific contaminant removal resin. You should be aware what it removes. The last one is this remineralization. So remineralization works for a certain volume of water. So if you see the cartridge specification, it will say how many liters of water which it remineralize and what is the quantity of remineralization. Right? Is it sulfate, calcium sulfate? Is it sodium carbonate which is getting added? It is magnesium sulfate which is getting added. What is the mineral which is getting added? That we'll have to see. So well, there is a material called meso, which is a natural ore which gives out calcite, so which increases little calcium, but after say 2-3 months of it, it doesn't actually remineralize it. So we should be aware on what mineral does it add, right? So for your specific things, sir, this acidity problem and things like that, so you should be aware if it is chronic acidosis, then you should experiment on this. But I think the best thing would be to measure the quality of water at the outlet and then decide whether you need remineralization. Remineralization in most cases, 2-3 months after that, it might not have enough remineralization happen. Right?
They say they have to change the cartridge every 3 months or so in the alkaline pitcher. But my concern is, will the cartridge bacteria grow inside the cartridge?
Yeah, so it can grow if it is not filtered. If there is heavy bacterial inflow, then it will grow. But generally, what happens in any purifier, you will have pre-filtration, you will have cartridge filter, you will have some pre-filter before it goes to all these stages. So before activated carbon, you will have a cartridge filter with you, if I assume. So if it is a standard one, you will have a filtration before it goes to your RO. For you, you should be aware that you have RO supplied water already coming to your purifier. So you cannot RO it again.
Yeah, I'm putting the RO water into the alkaline pitcher.
Right. It should be fairly good. So I think it is better to get it tested and understand if the calcium levels and magnesium level before your alkaline pitcher and after your alkaline pitcher. If you measure, then I think that.
Thank you.
Thank you, sir.
Thanks, Ramesh. Mr. Madhu Mangapati, please go ahead. Yeah. Next was your question. Yeah.
Hi. Hi, also, because I have one question. So we have been using RO water for quite some time. And then because of gastric issues for my wife, one of the Ayurvedic doctor, he suggested for one kind of a filter, which will increase the alkalinity. So if I look at that filter, it's a steel can which has multiple layers, which primarily a small size limestones and the biggest size limestones and the activated charcoal and the river sand, all that. So after RO, they suggested to put the water into that filter. And then after that, we can drink that. So that will increase the alkalinity, all that. So is that the right approach to increase the alkalinity, or is there any issue with that?
I wouldn't know what they actually use, but generally, any limestone, they probably add some mineral. If the alkalinity is getting increased, then it will add value. But again, so carbon, all these rivers and all these does not change pH significantly. There is no change. That limestone filter which you are saying, we don't know what composition is there in that filter. pH, generally, if there is mineral being added, there could be some change in the pH.
Yeah, one
but
issue.
RO, if it is a problem, pH. So the easiest thing you could do is the pH. You get pH strips available in Amazon, very, very cheap strips which are available in Amazon. So after RO and after alkaline filter, you can check the pH strip. It is one strip where it will indicate color. So if it is acidic, it will indicate one color. If it is alkaline, it will indicate one color. That pH, if you see, you'll be able to see whether it is performing well or if it is not performing.
Yeah, so I did that, and one of this marketing people who came to one of my friend's place, they wanted, because my friend told that we are using that, they tested this water. They said it is too much alkalinity is there. So it is kind of, they're saying it's more than 10 or so. They're suggesting that it is not really good because it was showing it's too alkaline to use it.
So we should not play with alkalinity, meaning that is, we have had people gone through worse thing. So it is better not to take it above the standards. 7.5, 8 above that, it's better not to take. 10 is definitely, until otherwise doctor has advised specifically for 10 for a specific duration, then it's good. It can't be a replacement for normal water. For sure, you can't take 10 pH water continuously.
Okay. Thank you.
Sure.
Thanks, Mr. Madhu. Apeksha, go ahead. Please ask your question.
Yeah, hello, Vikas sir. I'm Apeksha and I'm working in Biome Environmental Trust, and I also work in Devanhalli project. So thank you very much for explaining each and every component of that water quality, because we do keep getting those water quality now and then. So it was helpful. My question is not really relevant to today's topic, but I just wanted to know what is the major difference between secondary and tertiary treated wastewater, and how does it happen? Like, Devanhalli does get secondary treated water, no? So I just wanted to know more about that.
Yeah. So again, secondary, tertiary treatment is a loosely used term. So
Okay.
in an STP, when there is secondary treatment, it's basically biological treatment, basic filtration, bar screen, and biological treatment ends up at secondary. Most of them call sand and carbon filter and chlorination as a tertiary treatment in most of the STPs. So they call just put sand, carbon, and chlorination. They call it as a tertiary treatment. But in a real sense, when we do tertiary treatment, it has to be a really advanced treatment after the basic treatment. So when we use the tertiary treatment, it will be potable water production from STP when we use advanced tertiary treatment. But it is loosely used. So when someone says secondary, we just have to ask question: is it secondary just biological treatment, or does it pass through sand, carbon, and you have chlorinate and then send it? Now, as per norms, any government STPs is probably a little advanced secondary. They have biological treatment, they have multiple filtration, and then some places they have UF also. So if you see Jakur, they have UF, meaning UF treatment as well, and then take it. So that some people say tertiary treatment is there with UF. Some people say that also is secondary. So it is not clearly used by different people. Different people use it different.
Okay. Because like after when we pass it through the WTP and a couple of filtration in Devanhalli, we tell that the resultant water is potable, which is kind of tertiary. So is that what
Yes.
the
So
tertiary
if we
treatment?
bring it to potable quality, with advanced tertiary treatment, then we can say it's a tertiary treatment. Our
Okay.
treatment will be a tertiary treatment.
Okay. Thank you, sir. Thank you.
Thank you.
Okay, for those who didn't know, WTP is water treatment plant. STP is sewage treatment plant. There is a question from Mr. Satyanarayana again. He wants to know if you can share your contact for future queries.
Yeah, definitely. Definitely we can share. Should I
Okay.
say it here or?
Yeah, if you can put it in the chat, it will be good. Okay, I had a question actually. Okay, you put your contact and I will ask the question. The question I had was that a lot of people now, because RO, there are so many brands of RO filters, and the ad campaigns are like so in your face. They're there all over the place and they're being pushed. People generally just go and buy an RO filter and put it up, including places where the main or maybe the only source of water is Kaveri water. And you had shown, right, that in a house, the Kaveri water TDS is around 130. So for that, RO is not necessary at all. So would that RO filter actually cause health issues because it will reduce the TDS further from 130?
Meaning what we get on 130, say we take Kaveri water in Malleshwaram or Jayanagar region, where the pipeline is all built, meaning you won't have lot of variation, people cutting pipeline, all that is not there. In that case, we don't need an RO because the mineral 120, 130 is good. Now, if they pass that via RO and it will go to 8, 7, then there could be harm, but we really don't know. So it comes under the demineralized water, right? We don't know. Based on the reports which is available, people say at 0, 1, 5, it can extract mineral from the other parts of the body. That's what people say. But there is no in-depth study based on our water condition. But the other point of fight is, now if the same Kaveri water is coming to HSR, 180 ppm, 170 ppm, we have 4 or 5 times during the year there is pipeline cut, and we get black color Kaveri water coming to our summer, right? We don't know what all is coming in that water, and someone calls us, asks us to clean some. Last year we did 2 times black color water coming to the summer, right? In such cases, how do we rely on the quality of water? So we end up invariably putting RO for that. So for your question, do we really need RO if the water is tested? So if it is 130 ppm, 120 ppm, probably a UF and a carbon in series with sediment filter is sufficient. We don't need an RO. But for you, me, we see water in, day in, day out. We know the water report, all that. But someone doesn't see the water, and they don't know what they are getting. Say in HSL, they don't know what they're getting. So it becomes easy to put RO. Will it cause long-term health effects having just RO? I think it will be lesser than other contaminants which will actually cause problem. So say in HSR, we say you are getting Kaveri water. Let's ban RO in HSR. Now, tomorrow, day after, they open a pipeline, there is sewage entering, there is other borewell water getting mixed and things like that. That will cause bigger problem than having an RO is what is my view. People who understand, get the water tested at these values, it is not required. And government also says that it is not required, provided we take the water quality check in our hands and get it tested from an NABL certified laboratory. Again, testing, we know how people test. So we should give it to an NABL certified laboratory where the testing is done properly and not to convince people that the water is good. Because in laboratory, people say if we give bad report, next time they won't give the sample to us. So,
Oh God. Oh,
so
that is the most
people who
amazing.
get good report, they keep giving it to the same laboratory. So all these has to change. So people should give it to proper NABL certified laboratory and then get the water tested to know what is there in the.
So this means that everybody, I mean, whether they have, whether they, whatever, like in many houses, they will mix they'll have a bore well, they'll get Kaveri water and they'll mix the two in the sump and they'll use it also. So basically what you're saying is that everyone should test their water, like people who stay in independent houses, apartment, the managing committees, the layout managing committees, everyone should periodically, regularly test their water to see what quality of water is they are getting and accordingly determine what needs to be done, how it should be treated or filtered filtered, right? That's what you're saying. So are there any other questions? There are, looked at everything on the chat. Anybody else has any further questions? No more. Then thank you so much, Vikas. It was a really wonderful session and cleared so many doubts. And I hope all of you also found the session useful. Thank you once again for attending. Wishing everyone a happy new year. I completely forgot when we started. Thanks, everyone.
Thank you, all of you. Thank you. Thank you for patience. Thank you very much. Bye.
Bye.